We have spent a lot of time now talking about our solar system and some of the planets found in it. While I have not yet covered all of them, for today I would like to turn our attention outwards. Now, I would consider it safe to assume that if our star has planets, that most or all of the stars out there in our galaxy and maybe even universe have at least one planet orbiting them as well. Now, to check myself on this, I visited NASA's website and discovered that the professional astronomers think the same thing. This is Cup of Science Joe, and today we will be talking about exoplanets. We will cover what they are, methods we currently have for studying them, along with what we are able to learn about them from such great distances. And we will cover some of the prominent ones we have discovered as well. So, grab yourself a drink or a snack, and let's jump into the video. Let's go ahead and start with what exactly an exoplanet is. This is best described as any planet that is beyond our solar system. As I hinted at earlier, most of these orbit other stars. But did you know that there are also free-floating exoplanets out there? Ones that have in one way or another either escaped their host star, or perhaps never even had one. These ones are known as rogue planets. For exoplanets at large, so far we have confirmed the existence of around 5,200 of them out of the billions that we believe to exist. Most of the ones we have discovered so far are in a relatively small region of our Milky Way galaxy. In this case, small is within thousands of light years away from our solar system. The closest of these, which is Proxima Centauri b, is about 4 light years away from us, and we will touch more on this one later. We know that there are more planets out there than stars in the galaxy, and I suspect possibly even the universe as well. We can measure exoplanets' sizes, diameters, and masses, or weights, as a mean of learning more about them. We can see their composition ranging from rocky like Earth and Venus to gas-rich like Jupiter and Saturn. Some planets may be dominated by water or ice, while others are dominated by iron or carbon. Through gathering information like this, scientists have categorized exoplanets into 4 types: gas giant, Neptunian, super-Earth, and terrestrial. Now at this point you might be wondering, how exactly can we discover and study exoplanets when they are so far away? And also likely rather dim, given that they will at best be reflecting light from their host star, or maybe putting off their own light from their formation. And the answer to this is that we have several methods available to us for exploring and locating exoplanets. Let us start by going back to the year 1995. A year where I was actually alive. I was 5 years old then, when the first exoplanet was confirmed. This was done using something known as radial velocity, or the wobble method. This method measures changes in a star's radial velocity. The wavelengths of starlight are alternately squeezed and stretched as a star moved slightly closer and then slightly further away from us. Now those gyrations are caused by gravitational tugs by its orbiting planets. Planets such as 51 Pegasi b. This planet is a hot star-hugging gas giant believed to be around half the size of Jupiter. It tugged so hard on its parent star as it raced around in a 4-day orbit that the star's wobbling was obvious to our telescopes here on Earth once astronomers knew what to look for. Finding this fast-moving gas giant kicked off what might be called the classical period of planet hunting. This early technique of tracking wobbling stars revealed one planet after another. many of them being large, hot Jupiters with tight, blistering orbits. But not all of the planets we discovered with this method fall into this categorization. The closest exoplanet to us, which I mentioned earlier, Proxima Centauri b, was also discovered using this method. And this exoplanet is classified as a super-Earth, as it is close to us in mass, about 1.07 times it. Its radius is 1.03 times that of Earth, so it really is rather close to us in size. It is a rocky world that hugs its M-type host star quite closely, having an orbital period of 11.2 days. And it was discovered in 2016 by the European Space Agency, or ESA for short, and it happens to sit within its star's habitable zone, but this does not mean it actually supports life. The chance does exist for that, though. Now, jumping back to our discovery methods, the next one I would like to cover today is known as the transit method, which is maybe the one most of us have heard of. This is us discovering exoplanets using dips in light. And for this, we turn our attention now to the years 2009 to 2018, the era of the Kepler Space Telescope. This marvelous piece of equipment ushered in what we might call the modern era of exoplanet hunting. Kepler settled itself into an Earth trailing orbit and fixed its gaze onto a small patch of sky. It would go on to stare at this patch for 4 years. What Kepler would observe here is quite fascinating to me. Within just that small patch were 150,000 stars. This telescope was waiting to catch tiny dips in the amount of light coming from individual stars. Dips that were caused by planets crossing or transiting in front of them. And this is what we call the transit method. Once a planet has been detected, its orbital size can be calculated from the period and mass of the star. For those wondering, the period is how long it takes the planet to circle once around the star. Now, Kepler may have ended its mission in 2018, but you know what? Its legacy continues. Launched in the same year was NASA's Transiting Exoplanet Survey Satellite, or TESS for short, and it employs the same technique as implied by its name. It surveys large swaths of our sky, hunting for exoplanets. Let's touch on for a moment some of what we can do with the light we are gathering from these transits, which essentially is using it for spectroscopy. As our telescopes become more advanced and can obtain sharper images, we begin to scrutinize the atmospheres of extremely distant planets more and more, and even begin to capture direct images of some of these worlds. Once this light is captured, it can be probed to reveal things such as composition of the exoplanets, their atmospheres, and other information like chemical makeup of them. For a quick rundown on spectroscopy, think of a prism. If we were to shine white light through it, it would split the light into the rainbow spectrum that made it up. Scientists can read the color bands of this spectrum like a barcode, which reveals which molecules are present. This technique is known as transit spectroscopy. We have done this with Hubble, which has detected helium and water vapor in exoplanets, and we are beginning to get even more detailed profiles of exoplanet atmospheres coming from the James Webb Space Telescope. While there are some other methods for discovering exoplanets that exist out there, these are the ones that I wanted to cover for this video. Discovering exoplanets in general is awesome, but what I find also exciting is the fact that it is possible for some of them to be habitable, or in the habitable zone, and possibly even have life. Wouldn't that be cool? let's cover a couple of potential candidates. Starting with Kepler 22b. Now this exoplanet is 600 light years away from us, and it was the first Kepler planet found in the habitable zone of its parent star. However, this planet is considerably larger than Earth, being about 2.4 times our size, so it is unclear if this super-Earth planet is rocky, liquid, or gaseous. Its orbit around its host star takes it about 290 days, making it fairly similar to our 365. The exoplanet orbits a G-class star like our Sun, but it is smaller and colder as a star. Still, the possibility there exists. We also have Kepler 69c, which is around 2,700 light years away from us. This exoplanet is 70% larger than Earth, so like the previous example, scientists are unaware of its composition. It completes one orbit every 242 days, making its position within its solar system similar to the position that Venus is in ours. But its host star is about 80% as luminous as the Sun, so putting those together, that should place this exoplanet also within its star's habitable zone. And the last example I would like to give today is Kepler 452b. This exoplanet was discovered in 2015 and is 1,400 light years away from us. I picked it because this is the first near-Earth-sized planet that orbits around a star roughly the size of the Sun that we found out there. Kepler 452b is about 60% larger than Earth, and its host star is about 10% larger than our Sun. The star, known as Kepler 452, is very similar to our Sun in general, and the planet rests in its habitable zone. Because it is closer to the size of Earth than some of the previous examples and other discovered exoplanets out there, there is a greater chance of it being a rocky planet like Earth is. Its orbit is just 20 days longer than our own. Now, whether or not we ever actually discover life on a distant exoplanet, I still find it fascinating that we have the ability to even try to research and look into these things. And with the catalog of exoplanets continuing to grow, who knows what we might find next? That right there is part of being on the frontier of new discovery and the unknown. So what was your favorite part of today's video? Or do you happen to have a favorite exoplanet? I would love to hear your thoughts in the comments below. And if you would like a more in-depth video on spectroscopy, which we touched on earlier, please have a look at this video right here. Or actually, maybe it's right over here. I can never remember. With that, I hope you learned something, and I implore you to step outside tonight and look towards the stars.